Assalamu alaikum. Hope you all are doing well. Today, our topic is confidence interval estimate of the difference between two population means. So, when we have two separate populations and we want to uh, estimate the confidence interval of their difference, this is quite similar to that of the difference between the sampling distribution of the difference between population mean. So the formula will be quite similar, or it would be nearly similar, or I think you will be a bit familiar with this now. So now, confidence interval estimate of the difference between two population means for large samples. Large sample here means when uh, N1 and N2 there would be two samples, so one sample size of first sample will be represented by N1 and the sample size of second sample will be represented by N2, and if they both are greater than or equal to 30, this is meant to be large samples. So if you have large samples, so how you will compute or calculate the confidence interval estimate? Let's see. When the populations are normal, means the populations are taken from the normal distribution, and sigma 1, which is the standard deviation of first population, and sigma 2, which is the standard deviation of the second population, are known, then you are going to use this first one formula, and this formula says that x bar 1 minus x bar 2 minus z alpha by 2. In last lecture we have discussed this in detail, and then whole under root sigma 1 square by n1 plus sigma 2 square by n2, which is less than mu 1, which is population mean first, and second population mean is mu 2. So mu 1 minus mu 2, as we are discussing about the difference between two means, so this difference is represented by mu 1 minus mu 2 is less than or equal to, uh, again this and just positive. Here first one is negative minus sign, and here is plus sign in the upper limit. So for first situation we are going to use this first formula. If the situation is slightly changed, that is when the populations are normal but sigma 1 and sigma 2 are unknown, and n1 and n2 are large, which is greater than or equal to 30. If the population standard deviations for both populations are unknown but N1 and N2 are greater than or equal to 30, then we use the second formula, in which we replace this sigma square by capital S square, which is sample standard deviation. This S is sample standard deviation and sigma is population standard deviation. So let's see in the questions. First question is taken from the exercise number 15, question number 15.31, part B. A manufacturing company consists of two departments producing identical products. It is suspected that the hourly outputs in the two different two in the two companies, that is different. So two random samples of production hours are respectively selected, and the following data are obtained. Now from first department, this sample size of 64 is collected or obtained, and the mean is 100. And for second department, 49, and mean is 90. Now the variance of hourly outputs for the two departments are known as sigma 1 square is equal to 256 and sigma 2 square is equal to 196 respectively. Find the 95% confidence limits for the true difference. So as per first condition, which was that the population is normal and sigma 1 and sigma 2 are known, so we are going to use this formula because here population is normal and sigma 1 and sigma 2 squared are given. So as population variance are known, so we use the following formula for confidence interval for the true differences. So for true difference, which is equal to mu1 minus mu2, this is the confidence interval. Now first of all we will write the given data which is given to us. X bar 1 is given to us, which is 100, x bar 2 is 90. So as the data is given to us, accordingly we have written here, and z alpha by 2 directly I have written 1.96 because in last lecture we have discussed this in detail. We have discussed the use of z table in detail, so you can see it or you can review the last lecture again for this. So now directly putting the values, so we'll put the values in this formula, and here we have put the values in the data, and accordingly we solve this formula. And step by step, when you solve this formula, you get the final answer, which is 4.46 is less than or equal to mu1 minus mu2, which is the true difference, is less than or equal to 15.54. So this 4.46 and 15.54 is the 95% confidence interval for the true difference, which is mu1 is equal to, mu1 minus mu2. So this was for first question. Now the second question is also taken from the chapter number 15, question number 15.34. A random sample of size n1 is equal to 100 yielded the sample value x bar 1 is equal to 509 s square. This is capital S square. Capital S square is equal to 950. A random sample of size n2, which is equal to 100 from another population, yielded x bar 2 is equal to 447, and s2 square is equal to, which is the variance of second sample, is equal to 876. Find the 95% confidence interval for mu1 minus mu2. So again, as the population variances are unknown, so we use the following formula for confidence interval of the difference. So here we use, instead of sigma, we use s1 square and s2 square. Again, according to question, we have written all the information which was given to the question, and z alpha by 2 again with the same method we have seen from the table. And we have here I have written directly the value, and now by putting the values in the formula, appropriate formula, and by step solving the question, again we got two limits, which is 53.62 and 70.38. So 53.62 and 70.38 is the confidence interval for mu1 minus mu2. Now, confidence interval estimate of the difference between two population means for small samples. Small samples mean that n1 and n2 will be less than 30. So when populations are normal but sigma 1 and sigma 2 are unknown to us, or also n1 and n2 are small, which is less than 30, then we are going to use this formula. This formula is quite changed from the above formula, because here we are going to use t-test, And one thing in addition is here, that is SP, which is called pooled standard deviation. And this inside this standard deviation, we will write 1 by inside this under root we will write 1 by n1 plus 1 by n2 and up to so on. So what is this SP, or pooled standard deviation? It is equal to n1 minus 1 into small s1 square plus n2 minus 1 into small s2 square divided by n1 plus n2 minus 2. So this is the formula for s1 and this is the formula for s2 square. So accordingly we will solve these questions and we will see that how we will use this formula and this SP in the question. So for this, in your book, chapter number 18, question number 18.9, part A, give two given two random samples of size n1 is equal to 9 and n2 is equal to 16. Now here you see that both n1 and n2 are less than 30 from two independent normal populations, and populations are normal, with x bar 1 is equal to 64 and x bar 2 is equal to 59. Small s1 is equal to 6 and small s2 is equal to 5. Find a 95% confidence interval for mu1 minus mu2, assuming that sigma 1 is equal to sigma 2. Now here we assume that sigma 1 is equal to sigma 2, but the value of sigma 1 and sigma 2 is not given. So the condition is that sigma 1 and sigma 2 are unknown, populations are normal, and n1 and n2 are less than 30. So we will use the formula here, which is x bar 1 minus x bar 2 minus t alpha by 2 nu into SP, which is pooled standard deviation, under root 1 divided by n1 plus 1 divided by n2, and then for the second limit. So now again we have written the uh, given population which was given to us. Then 1 minus alpha is equal to 95 and 0.95, because 95% confidence interval is here. So 1 minus alpha is equal to 0.95. Then alpha will be equal to 1 minus this 0.95, which will be equal to 0.05. Now alpha divided by 2 is 0.025, and nu in this case, in two sample case, nu is equal to n1 plus n2 minus 2. So n1 is 9, n2 is 16 minus 2, so we get 23. Now when we look into the table, in front of 23 and below 0.025, we'll just see it. Yes, this is the table for t distribution. So in front of 23 and below 0.025, here we get 2.069. 2.069. Going back to the slide, so here I have written 2.069. Now putting the values in the formula, so one by one we put the values in the formula, but here the value of SP was not given, so we solve it by ourselves. We have put the values in this formula of SP, and then we got the final value of SP, which is 5.37. So here again I have put all the values in the formula, and step by step Accordingly, I have solved the question, and then final answer we got it 0.33 to 9.67. 0.33 to 9.67. So 0.33 and 9.67 is the uh, 95% confidence interval for mu1 minus mu2. So this is all for today. Thank you.